You guys are wasting your time already. Okay, so here we go. Pay attention. Good. So number one, so this is regular square roots. We've done this stuff before. We need to break it down. So if I put down, first of all, you guys know, if you don't know the perfect squares, you can always put those up here. Perfect squares. Okay, perfect squares. Those are like, 4, 9, 16, 25, 49. Oops, I forgot 36. 36, 49, right? Yeah. 36. Oh, 49. What's the next one? 64. Right? Oh, 100, right?
That was 100.
Yeah, 121, 144, and 169. Okay, those are our perfect squares. And then we're going to talk about our perfect cubes in a little bit. I'll put those up there too, okay? So, 32. Gosh, I'm thinking, how about 16? How about 16, right? Yeah, you're way ahead of me. 5 times the square root of 16 times the square root of 2, right? We've done this before, right? We're looking for two numbers that multiply to make 32, but we want one of them to be a perfect square, okay? And we know the square root of 16 is 4. 5 times 4 is 20. So we get 20 square roots of 2. Okay? Thumbs up? Thumbs up? Good. Thumbs up. Okay. Number 2, there's one rule we have to be careful of, and we want to take half the exponent, okay? So I want to take half of 5, but the problem is 5 is like an odd number. So I'm going to make it even. So I'm going to rewrite this, 5x. There's no multiples of 10, by the way. 10 is just a bad number, so I'm going to leave it 10 because 2 and 5 and 1 and 10. So I'm just going to keep the square root of 10. I can't do anything with it, but the square root of 5, this x to the 5th, we can rewrite as x to the 4th times x. So now we can take half the exponent. Alright, so if I do that, I'm going to have 5x square root of 10 x squared, because half the exponent is square root of x, okay? How am I doing? I want to go slowly so everybody kind of understands this, alright? And then I'll have a 5x cubed, see the 5x cubed, square roots of 10x. Okay, ask me if you have a question. Yes, Anna.
If the number was 7, would you just make it 6 and then x to the
1. Yeah, and then I would.
So it doesn't matter if it's like a square, like x to the 4th, it can be any even number.
Right, you want, but I usually take 1 away from it. So.
But I mean, like it doesn't matter if it's x to the 4th versus like.
Yeah. Right. So if it's x to the 7th, I'd make it x6, x1. I always take 1 away so I can take the most out. And I go down to x3, right? But if it's already even, like say, if it's already x to the 8th, then I just take half of it, right? Because I want to take half of it. So if it's an odd number, take 1 away. So take 1 away and make it even, okay? Because then take half of the even one, okay? Does that make sense? Okay, good. All right. Oh gosh, 3 is easy, isn't it? Just 7/9. Isn't that it? Just 7/9, right? Yeah. Now 4. 4's got a few problems. I might have to do 4 on a separate sheet of paper. I might need more room. So I'm going to do 4 like here. So I'm going to rewrite 4 as the square root of 8 over the square root of 7. Okay, I'm going to start right there, okay? Now I know that 8 can be broken into square root of 4 and the square root of 2 over the square root of 7, right? Square root of 4, I can do something with that. I can make that 2 square roots of 2 over the square root of 7, but there's one problem. You can't have a square at the bottom. So we fix the problem with the problem. Fix the problem with the problem, so we multiply by the square root of 7 for square root of 7. And I'm going to get 2 square roots of 14 over, you ready? Square root of 49, which is just 7. You okay with that? That's really tempting to divide the 14 to 7, but don't. That's not really a 14. That's really like a 3.4 blah, 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 blah. It's really an ugly number, okay? No, not even 3 point. Yeah, 3.4 blah, blah, blah. Maybe. I don't know. What is square root of 14? I don't know. I don't know. Let's find out. Square root of 14, 3.7. So see, it's not really a 14 at all. So just leave it right there, okay? Okay, number 5. Again, I don't know if I have enough room. I might have enough room. I'll just do it on a separate sheet of paper, okay? I'll do 5. I've got 4 square roots of 5 times 3 square roots of 15. Okay, so I'm just going to multiply. I'm going to multiply and have a 12 square roots of 75. Just multiplied regular number with regular number, square root number, okay? So then that's a 12, and the square root of 25. We can break that up. We can break it up to 25 times 3. And I want 25 because 25 does have a square root. Okay, so then I'm going to take the square root of 25, which is 5, and then 12 times 5 is 60 times the square root of 3. Okay, stop me if you get confused. I want to make sure that I do my job and you do your job, okay? Everybody okay with that one? Okay, let's look at number 6. And again, I'm running out of room, so I'll put it right here, okay? Put 6 here. 6 is a little bit bigger. I'm going to have a 4x cubed square roots of a 2x times a 2x square roots of a 6x to the 5th, okay? So it's the same type of problem. We just have to multiply. I'm going to get 8x to the 4th square roots of 12x to the 6th, okay? Well, I want to take half of this, which I can, right? But let's break up the 12 also. So let's go 8x to the 4th. So I'm not doing anything with that. Just straight down, 8x to the 4th. The 12 I'm going to break down into 4 and 3, because that would be a good multiple. And I'm going to take half of the exponent, okay? So I'll make that an x to the 3rd. So when I do these, I'm taking the square roots of them. When I do these, like when I take half of it, I'm actually taking the square root of it, so I don't write it in a square root, okay? Now I'm going to finish it up. That becomes a 2, right? So I'm going to get a 16 x to the 7th square roots of 3. How am I doing? Okay, I know you guys can do this. Okay, number 7, all right. Let's do number 7 right here. Okay. So, to do number 7, there you go. You can see 7 right there. So I've got 4 square roots of 5 times 5 square roots of 5 minus 2, right? I'm going to go this times this times this. I'm going to distribute. So I'll go 4 times 5 is 20. And the square root of 5 times the square root of 5 is the square root of 25. Okay, so 4 square roots of 5 times 5 square roots of 5. And then minus 8 square roots of 5. Okay, now there's a little bit more work I can do, right? I can do more. I can take the square root of 25, which is 5. I'll go 20 times 5 minus 8 square roots of 5, right? And 20 times 5 is 100 minus 8 square roots of 5. There it is. Okay, how am I doing? Thumbs up? Good. All right, number 8. Let's put number 8 here. And am I going slowly enough? Okay. All right, number 8. I'm going to have a 2 square roots of 7 plus 1 times the 7 square roots of 7 minus 1, okay? So we're going to FOIL. We're going to FOIL. This times this, 14 square roots of 49. This times this, minus 2 square roots of 7. This times this, positive 7 square roots of 7. And this times this is minus 1. Okay, how am I doing? Okay, I'll let you catch up. Alright, square root of 49 is 7, so I'm going to have a 14 times the 7. These two we can combine to make a positive 5 square roots of 7 minus 1. Okay, 14 times 7, I don't know. 14 times 7 is 98. So we've got 98 plus 5 square roots of 7 minus 1. And then I'll take 98 minus 1, and I'll get a 97 plus 5 squared root of 7. Okay? I don't think you're going to find this test that hard, because you guys already know how to do square roots. You guys are good at it. Okay, we're ready for number 9. Am I going slowly enough? Okay, number 9. 9 right here, okay? So with 9, I'm just going to add them up. So the only two that are the same are these two, right? So I'm going to get a minus 1 square root of 5 plus 8 square root of 3. And that's it, believe it or not. That was a really easy one, isn't it? Combine the ones, add or subtract the ones that are the same, and then just bring along the ones that are different. Okay, number 10. And 10's a little bit different because it looks like you can't add them, but you really will be able to once we reduce them. So on number 10, we've got a square root of 27 plus 3 square roots of 48. Okay, so if I reduce these, maybe I can add them. So 27, how about 9 and 3? 48, you're probably not going to know this one, but 16 and 3 is the best combination. 16 and 3 is faster. Now you could still do 4 and 12, which will work. And then you could break down 12 into 4 and 3, but either way, you can still get it if you broke it down into 4 and 12. Anyway, from here, though, it gets pretty easy. I get 3 square roots of 3 plus 3 times 4 square roots of 3. 3 square roots of 3 plus 12 square roots of 3 makes 15 square roots of 3. Thumbs up on that one? Okay. Yep. I know you guys can do this, okay? All right, let's look at number 11. All right. Number 11. All right. Okay, 4th root of 16x to the 12th. Okay, now if it's 4th root, we've got to think, okay, what times what times what times what makes 16? What times what times what times what makes 16? 2. Check it out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is just plain old 2. Now, instead of taking half the exponent, we take a fourth of it, right? Take a fourth of that, and we get x to the 3rd. That's it. Okay, now, 12. Now, the problem with 12 is that 32 is not a perfect root, but by doing this 11, we kind of got a clue. So if I rewrite 12 as, you ready? The 4th root of 16 times the 4th root of 2. We already know there's an answer to this one, right? We just did it. We just know the 4th root of 16 was 2, right? So we can make that into a 2. And then if we take, like we did before, take a fourth of that, we get x to the 3rd. Then all that's left over is the 4th root of 2. Now that's a little bit harder. But the nice thing is we did one just like it prior to it. The only difference is that 32 is 16 times 2, okay? A little bit harder. All right, 13. Okay, do 13. I want you to write down all the perfect cubes. Let's write them down up here, okay? Perfect cubes, okay? Let's write them somewhere. Perfect cubes, because you want these in your notes somewhere. Perfect cubes. 8, 27, 81, 125, what is it, 246? Oh, hold on, I'll tell you a second. What is it? 216. I think that's all the further you need to go. Okay, thanks, Austin. So these are your perfect cubes, right? So then here's the thing. So if I rewrite this, 13 as, you guys see this? As the cube root of 3 over the cube root of 25, right? Now, you can't have a root in the denominator. You can't. But can you make this number here into one of these? Can you make this 25 into one of these? Yeah, we can make it into 125, couldn't we? So if we make it into 125, but how do we make it into 125? Multiply by 5, right? So multiply both top and bottom by the cube root of 5 over the cube root of 5. And let's see what happens, okay? So then we'll get on top, we'll get the cube root of 15. And cube roots on the top are fine. There's nothing we can do with it. It's just, we're just stuck with it. That's the way it is. But down on the bottom, you're going to get a cube root of 125, which I kind of like that number, right? Because I can take the cube root of it. It's one of our special ones right there. So our answer, ready? Our answer is the cube root of 15 over plain old 5. Don't divide those, because that's not really 15. It's some ugly decimal thingy, okay? 2 point something or other. Okay, okay, 14. We'll do 14 over here. 14's not bad, okay? This is AV, you ready? There's 2 ways to do it. You can actually use your calculator. I'm going to show you. I am. Here's the way I would do it, because for me it's faster this way. But for 14, I would do it like this. I would do 1 over. Okay, I'll go 1 over. I go 1 over because of the negative, right? And then I do the 5th root of 32 squared, okay? 1 over 5th root 32 squared. So now the 5th root of 32, okay? So what times what times what times what times what? 2. It is 2, you guys are right. So the 5th root of 32 is 2, so the answer is going to be 1 over 2 squared, right? Which is just 1/4. Now let's see you want to use your calculator. I don't mind you using your calculator, right? You've got to figure out how to do it one way or the other. So if thumbs up if you like calculus better, right? Okay, check it out. Here we go. We're just going to go just like it says. We're going to go 32 to the power of, right? To the power of. 32 to the power of. Use parentheses because we need the entire thing to be in the exponent. Does that make sense? To a negative 2/5. Okay, see it? That's 32 to the negative 2/5. Boom. 0.25. Well, isn't that the same thing as 1/4? Yeah.
Wouldn't you take 0.25 as an answer?
Of course I would. They're equivalent, aren't they? Yeah.
Oh.
Right, do you like that way better?
Yeah.
But it only works if it's just numbers. If it's x's and all that stuff, then you know. But actually, 15's not so bad. 15's actually pretty easy. What do you know about a 1/3 power?
It's same as cube root.
Same thing as cube root. Everybody agree? So let's rewrite this thing as the cube root of 27x9y6. Okay? So what's the cube root of 27?
3.
It is 3. Everybody agree? Take a third of the exponent. So we get an x to the third. Take a third of the exponent. We get a y to the second. Bam. Kabam. Okay. All right. 16. All right. 16. Let's see. What about 16? Well, I'm going to do 16 on a separate sheet of paper. So you can't have a square at the bottom, okay? So there is a trick. So if I had 5, can you see that? Yeah. Over 3 minus square root of 5, okay? So there's a trick. It's a plus or minus. You're going to multiply by this thing called the conjugate. I'm going to multiply by 3 plus the square root of 5. Watch this. 3 plus square root of 5. So remember, our goal is no square at the bottom, right? Our goal is no square root right there, right? If I multiply by just square root of 5, we wouldn't get rid of it. But with a plus or minus down the bottom, we're going to do this whole trick. So what is the trick? Do you see where this minus is? So whatever the sign is, this is just the opposite. If this were a plus, I would have made this a minus. So it's called the conjugate. You're going to end up going, instead of 3 minus square root of 5, you're going to go 3 plus. So you write the same thing exactly, except for a different sign. Now watch why that helps us, okay? So on top, you get a 15 plus 5 square roots of 5. But on the bottom, check it out. This is why we do the conjugate. Okay, I'm going to FOIL it. 9 plus 3 square roots of 5 minus 3 square roots of 5. Oh, I like that because those are going to cancel, right? That's why we do it. And then we get a minus the square root of 25, but that just becomes a regular 5. So the whole idea of doing the conjugate is, when I get to here, hopefully, no, hold on. When I get to here, you guys see the fact that these two are going to cancel, right? Those are going to be gone, and then that becomes a 5, right? So let's see what we got, okay? So boom, boom, that becomes a 5, right? So 5 plus 5 square roots of 5 over 4. Because 9 minus 5 is 4, right? Boom, bam, there it is. No more square roots on the bottom. So we multiplied by a thing called the conjugate. I don't care if you remember the name, but if I use the name, you'll say, oh yeah, he's talking about the opposite of that, right? Am I doing okay? All right. Let's look at 17, okay? 17 actually is not that hard. 17 is actually pretty easy. Okay. All right. 4th root of 81 over the 4th root of x cubed. Okay. All right. Let's see. Let's think. What times what times what times what makes 81?
3.
It is. It is 3. 3 times 3 is 9 times 3 is 27 times 3 is 81. So we can go straight to bam. 3, right? Now, we're not supposed to have a square root or a cube root or even a 4th root in the denominator. But if I can make this into x to the 4th, right? If I can make this into x to the 4th, wouldn't I be able to take 1/4 of it? So let's multiply 4th root of x, 4th root of x, and let's see what happens, okay? So on the top, we can't do anything about it. That's just going to be plain old 3, 4th root of x over 4th root of x to the 4th, right? But then that's the cool part about that is that becomes just a x, right? So I'm left with 3 times the 4th root of x over x. Bam, there it is. Okay? All right, you ready to turn the page? Yes, no? Okay, I'll show you. Want me to wait for you? Graph paper. There we go. Sorry about that. Help me out. Okay, turn the page. All right. All right, 18. We did this the other day. F of x is equal to the square root of x plus 2 minus 1. Okay, now, whenever I graph square root graphs, now you can do it on your calculator, but the problem with the calculator is it doesn't really give you a very good picture. But I know that the main square root graph, let's put it on the side, main square root graph looks like this. Okay. Okay, and I'm going to okay, this is the main square root graph. Now, here are the important numbers, right? It's the 1, 4, and 9, right? Those are the important numbers because what's the square root of 4? 2. Square root of 9 is 3, right? And all the rest of these numbers are here, but they're just ugly decimals. That makes sense? Let's pick the easy ones. 4, square root of 4 is 2. 9, square root of 9 is 3. Except for this graph, we're going to move. So we're going to take this graph, and we're actually going to move it. We're going to put its endpoint. So we're going to put the endpoint, which is that. That's my endpoint. Endpoint at -2, -1. So all we're going to do is take this exact graph, boom, we're going to put it back at -1, or -2, -1. So let's do that. Okay, go ahead and find a ruler, and maybe some pen to make my axes. All right, there we go. Purple, why not? So let's take this exact graph. Let's just move it to -2, -1. Okay. So here's how it works. Remember we did the 1, 1, 2, 2, 4, 3, 9. Remember we did that 1, 1, 2, 4, 3, 9. Remember we're doing just the opposite. Just the opposite. We're going to go 1, 1. We're going to go 4, 2. We're going to go 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. And there it is. Now you can try this on your calculator. It's hard to see on the calculator, but I'll show it to you, okay? So let's say we go y equals clear. We go the square root of x plus 2, bam, subtract 1. We'll graph it, okay? See, it's there, but it's really hard to see it. Do you know what I mean? I mean, it's kind of hard to tell where the endpoint is. You guys agree? It's kind of hard. So I'd rather much do it this way. And then let's think about domain. Domain. Don't mess with my domain. How wide is this? William.
Oh, no, just wondering, how do you know the difference between that graph and then the other one that goes like down? And then...
That'd be a cube root. Great question. Instead of an x,
Oh, okay.
it'd be a cube root. Okay, very good question. Okay, domain. How wide is this graph?
Isn't it all numbers?
Not back here. Not back here. There's nothing back here. But I'm glad you asked that, right? Nothing back here. So it starts here at what value? And then it goes forward. So we're going to say domain is x is greater than or equal to -2, right? Starts at -2 and scoots over, right? Doesn't have anything back here because it can't. It can't. You'd have negative square roots, right? Can't do that. Reach for your range. What's its lowest value? So the range is y is greater than or equal to negative 1. Because it starts at a height of negative 1 and goes up. Does that seem easy? You guys can do this. I know you can, okay? All right, here we go. Y is greater than or equal to negative 1. Okay, last 4 questions. Some of them are really easy. Honest, that's good news. Kayla, you don't have your phone on. You are not using your phone. Of course you're not. You would not do that, I'm sure. All right, let's check it out. Let's do the next one, okay? Number 21. Can you see that? No, no, you can't. Okay, 21, there it is. So 21 is the square root of 2x equals 12. Okay, what are we going to do? What are we going to do? Square it. Square it, right? Because the square root cancels the square root, and then I'm left with 2x equals 144, right? And then divide by 2. 72, I think, is the answer. That should be a thumbs up, right?
Yeah.
Everybody can do that. That's piece of cake, right? We agree? All right. 22. Just as easy. Okay. What are we going to do? Square the square root. Perfect. Totally right, right? Agree with that? X minus 5 equals 225, right? Plus 5, x equals 230. Capiche? Kabam. Thumbs up. Easy. Easy. 23. Okay. Square root of 8x minus 5 equals square root of 2x plus 4. Okay, what do you think? Let's just square both sides. Square, square gets rid of the square root on both sides. I kind of like that. Boom, boom, right? Okay. And then we get just plain old 8x minus 5 equals 2x plus 4, right? Minus 2x, minus 2x. How am I doing? Am I going too fast? 6x minus 5 equals 4. How am I doing? Am I okay? Not going too fast. Plus 5, 6x equals 9. Divide by 6, and if you use your calculator, 9, 6, 3/2, or 1.5. Easy, huh? All right, 24. Uh-oh. We're going to have to factor. Oh, we don't have to worry about factoring. We got our poly button, right? Let's check it out. Okay, God bless you. All right, 24 is probably the hardest question, but it's not hard for us because we know how to use a poly button, right? Or factor. Okay, what are we going to do? Square both sides. But I gotta square this whole thing, right? How am I doing? X plus 18 equals, you ready? This will be x squared minus 4x plus 4. Wow, where'd that come from? Just wrote, did a little foiling, but I foil in my head because I know how to do my double smiley, right? I know my double smiley, right? See where my 4x comes from my double smiley, right? Okay, I'm going to have to factor. So let's bring over the x. So I subtract. I got to go minus my x, minus my x. I got to bring over my 18, so I'm going to subtract my 18, because it has to equal 0 before you can use the poly button. Okay, 80. We can use the poly button real soon, right? 0 equals x squared minus 5x minus 14. Now, if you know how to factor, you're just going to go boom to boom to boom to boom to minus 7 plus 2. You're going to get x equals 7 and x equals negative 2, right? But if you don't know how to factor, we got the poly button, right? So we go to apps. Remember apps? Go down to our poly.